Hello, welcome again. We are covering the subject compressible fluid flow for civil services mains, IFS and Gate Aerospace exam, and we are covering the topic oblique waves and expansion waves. So we have just finished oblique shock waves. Now we'll start expansion waves under heading Prandtl Meyer expansion waves. So this is your oblique shock wave, and that we have studied. Here the Mach number was more than 1 and the wave was turned into itself, or the flow is turned into itself. So here the flow is like that and it is turned into itself after shock. Whereas in case of expansion waves or expansion fans, the flow is turned away from itself. So this is the flow and it is turning away from itself. So this is your expansion wave, or as there are many waves, so this is called expansion fan. So this is your concave corner, this is your convex corner. So here another difference is here the Mach number is more than 1 and the Mach number increases here. M2 is also greater than 1 and M2 is greater than M1 also. Pressure, temperature, density decreases across the expansion wave. So reading this out, when a supersonic flow is turned away from itself, an expansion wave is formed as shown in figure B. This is directly opposite to the situation when the flow is turned into itself with consequent shock waves as shown in figure B. Expansion waves are antithesis to shock waves. These are opposite to this shock waves. To appreciate this more fully, some qualitative aspects of the flow through an expansion wave are acknowledged as follows. So qualitative aspects are properties. M2 is greater than M1. An expansion corner is a means to increase the flow Mach number. The first quality is to increase the Mach number. P2 by P1 less than 1, rho 2 by rho 1 less than 1, P2 by T1 less than 1. These pressure, temperature, density decrease across the expansion wave. Okay. So now this is the introductory part. So if we analyze this expansion fan, so here this is the front wave is called, or front line is called forward Mach line, and the rear line is called rear Mach line. And there are many lines in between, or we can say infinite lines in between. That's why it is called expansion fan. Okay. The first line, so this is your first line or forward Mach line, and this is your last line, or it is called rearward Mach line, makes an angle mu1 with the direction of flow. So this is the flow direction initially. So this is angle mu1, and this mu1 is related to this Mach number, or this is called Mach wave angle of upstream flow. Similarly, the rearward Mach line makes an angle mu2 with the final direction of the flow. Final direction of the flow is like this, and it is related to m2, or this is called rearward Mach angle. Okay. So now the next point is according to this. The expansion fan itself is a continuous expansion region composed of infinite number of Mach waves bounded upstream by mu1 and downstream by mu2, where mu1 is sine inverse 1 by mn. This is the Mach wave angle, sine inverse 1 by mn, and mu2 is equal to sine inverse 1 by m2. So this is your expansion fan. This is corresponding to sine inverse 1 by m1. This is corresponding to sine inverse 1 by m2. So here we can see that there is a continuous change like this. This is curved within the expansion fan. Streamlines are curved. As compared to this, here there is sudden change. So the streamlines are curved and the flow is just isentropic. So next quality is, these are also the quality, and next quality is streamline through an expansion wave are smooth curved line. Fourth quality. And fifth quality is Since the expansion takes place through a continuous succession of Mach wave and ds is equal to 0, for each Mach wave expansion is isentropic. So here for each Mach wave the expansion is continuous or isentropic. This is your forward Mach line, this is rearward Mach line, this is initial Mach number, this is final Mach number. P2 is less than P1, P2 is less than T1, ρ2 is less than ρ1, and this is your initial Mach angle, or this is your final Mach angle, and it is given by sine inverse 1 by m1, and this is given by sine inverse m2, 1 by m2. Okay. So these are the qualitative aspects. So in next video we will study the quantitative aspects.